All right, welcome back, everyone. We're going to continue on with our discussion of the conditionals, those if statements. Let me go ahead and share my screen, and we will continue on our way. So last time we got an introduction to how we would actually use the if statements. We also took a look at the input and the dummy proofing and dealing with those edge cases to make sure that everything runs smoothly. And we saw how to actually set up a simple if statement. If some condition is met, then we would have a block of code that is guarded by the branch, the if statement with a Boolean in it, to actually execute the code. So now we're going to continue on because there are other additional syntaxes that we can use to handle more complex situations. So we'll be taking a look at the alternative execution and the chain conditionals in today's lecture, and then we'll round out the week with multiple alternatives and nested conditionals in the next time. So let's talk about alternative execution. Alternative execution is the structure that has if and else. If a condition is met, then something should happen. And if it's not met, else, then something else should happen. So we could draw that with this little block diagram over here. There's some condition that needs to be met, and either yes it is or no it's not. Returns a Boolean, true or false. So we have the true side and we have the false side. If it's true, then the if code, that is the thing that we've coded into that branch, is the part that gets run. But what if we wanted to also run some code if the situation were false? So we can also do that by having some else code. When something has to be done contingent upon some condition, and if the contingency is not met, do something else, which is why we use the keyword else. Again, we use the Boolean type to decide. We'd add an else clause to form an if-else statement. Else must be associated with an if block. You can't just have else all by itself. That doesn't make any sense because it needs to be besides something else. And what's that other thing? Well, if you didn't define one, that logically doesn't make any sense. So we're going to have to make sure to have the if else block. Make sure that you, whenever you have an else, that you also have an if that it goes with. It's possible to have if by itself, as we saw before, but if you have else, you must have it connected to an if, which is why we call it the block, because they're linked. A branch guard determines whether it will run. If the Boolean evaluates to true, the branch associated with it will run. Otherwise, the branch with the else clause will run. Exactly one branch will run. You can't be true and false at the same time, so either one or the other is what you get. So this is what our syntax will look like. We'll have if and then the Boolean expression, just like we did with the regular plain if statements, the simple ones. We have the branch guard with the Boolean expression that will evaluate to true or false. And if it evaluates to true, then however many conditional statements we have in here, right? This is what you have to do. Write out a message, say congratulations, have a great Tuesday, whatever it's going to be. This is the true branch. Then we put the else. Notice that the else does not have a Boolean expression. Why doesn't it have a Boolean expression? Well, because it was yes or no to this Boolean expression. If this Boolean expression is true, then this happens. And the only other alternative is this Boolean expression is false, in which case that's when we execute the else. So if the Boolean expression was false, we don't need to test again. We just go right to the else. And then these statements are the things that we're going to do, probably provide the missing information or whatever else might need to be done. This is the false branch. So we see we have two branches. It's a binary choice. Either the Boolean expression is true, which we do these things, and if it's false, we do these things down here. Now, of course, the conditional statements just mean the body of your expressions here, right? It's whatever you want to do. It could be print, it could be prompting the user for input, many different things. And as we are working over the course of the semester, we'll learn more and more things that you can use to fill in here. And so there's no specific number that you have to have here. You have to have at least one. If you don't have something, you should use pass so that it skips over and doesn't make an error. So let's take a look at an example of some code. So here we're going to have a function called alt-x for alternative execution. Please enter an integer. Okay, and so we're going to coerce this into an integer. This is using the composition, and that will be returned into the variable called x. If x is less than 0, it will print x is negative, and now it's going to compute the square and it's to report that the square is positive and what the x squared value is. So it will do all of these things. So it's going to do 3 printings and also a calculation. This constitutes the body of this. This is the true branch. And then there's else. Again, see, there's no conditional here because it's else contingent upon this conditional up here. So if this one is false, it will print x is non-negative. So that's all you get. You could, of course, have more things here that you want to do, but right now this is the example we have. So let's see what it would look like when we run it. Please enter an integer. Right, so we do run module, and that invisible pointer comes down here and it's going to try to run this. Okay, so please enter an integer, and they supply -2. If x is less than 0, well, is -2 less than 0? Yes, it will do this. It's going to print x is negative, which it does right here. And then it's going to do the computation of x squared. So -2 times -2 is going to be a +4, and the square is positive. Yes, it prints that right here. And it will also print this. X squared is, and not surprisingly, it comes up with the answer 4. The else branch does not execute because the statement was true. Suppose you want to have a different outcome based on whether a number is odd or even. Do you remember that we had a test for evenness and oddness earlier in the course? Think about that. Using what you've learned so far, chat with your neighbor to come up with a Boolean expression to determine if a number is odd or even, then incorporate it into an if statement to check whether a number is even. Put your if block in a function odd or even that returns true if the number is even. All right, so you can feel free to pause the video and go ahead and try this exercise. And when you're ready, we will join you on the next slide. All right, so do you remember about the modulus? The percent operator, or the modulus, yields the remainder from division of the first argument by the second. If a number is even, then it is evenly divisible by 2. It follows that if the number is even, then the remainder when divided by 2 is 0, right? So we could simply just check to see if the remainder is 0 in computer speak, and that would give us a test to see whether something's odd or even. We could use this as an if-else statement, and let's see how that might look. Here's a function called odd or even. It's going to take that number of interest. The signature will be an integer, and it's supposed to return a Boolean, a true or false value, to tell us. So it's going to return true if the input number x is even, because it will return false otherwise. So here we have remainder equals number %2. So this is going to do the modulus with division by 2 to see whether it's on, whether that's 0 or not. And so here is where we're doing that testing to see if it's 0. If the remainder equals 0, right, the result of this, which is the mantissa, or the however much is left over. If there's nothing left over when we try to divide by 2, then it must be even, right? So we would return true. Else, it means it wasn't equal to 0, that it's not evenly divisible, it will return false. So now we have solved the problem. So here we have the rest of the code here out in main, right? So this is in the function, and this is not in the function, so this is in main. Num equals int input, please enter an integer, and then we're going to print odd or even of number, so it will return true or false, and this print statement will allow us to actually see it. Here we are showing the execution of this. It says please enter an integer, and we get 4, and so this will give us true because in fact that is an even one, and if they entered 3 instead, we would get false. That brings us now to another structure, and that is the chained conditionals. The chained conditionals have the form if, elif, any number of times. We could have a bunch of elifs. When something is to be done contingent upon some condition, and if the contingency is not met, check to see if other contingencies are met. Again, we're going to use the Boolean type to decide. It's kind of like multiple choice. The analogy only goes so far, but I like to think of these little toggle switches. You maybe seen them on some web pages or something. And as soon as you click on another one, it means that the first one you selected is deselected. We're going to choose among a number of choices. A branch guard determines whether it will run, right? These are going to be elif clauses to form those multiple branches, multiple choice is the idea here. The first Boolean that evaluates to true will have the branch associated with it run. Otherwise, the next condition is evaluated. So you're going to evaluate from top to bottom in the order in which they appear. At most, one branch is run. This is very important because it's possible that more than one branch is in fact true. But just because it's true does not mean that it's going to run. It is the first one that is encountered that is true is the one which will actually execute. So if multiple guards are true, the first one which is true is the one that will execute. If no guards are true, then none of the branches are executed. So then thinking about that, how many branches could execute in an if-elif statement? Well, could it be one? Yes, because one could be true and it would execute. If multiple were true, the first one that it encounters that's true is the one that's going to be executed, and none of the subsequent ones are going to be executed, which is why we call this flow control, right? You skip over the other ones. So that would also be one. What if none of the choices have a true branch guard? Well, then none of them will execute. So the possibilities are that one branch would execute, but it's also possible that zero will execute. And that is independent of how many branches are actually true. So let's take a look at chain conditional syntax. Here we have if, and then we have some Boolean expression, and then we would have our conditional statements that are associated with this. And then we'd have elif. So now, else means like else if. And so that's just abbreviated to elif. And so then we would need to supply a Boolean expression. Remember when we had else, we didn't need to supply a Boolean, but we need to supply a Boolean here because we're saying there's another condition that I want to test. So we have some other condition here, and then you would have your statements that go along with this branch. And now we have, so this dot, dot, dot ellipsis gives the idea that there could be more in here, right? So here I'm showing if with two elifs to have this block be consistent of if, elif, elif, but there are other configurations too, and they all work essentially the same way. You just have a different number of them, however many. Just like you could have a variable number of conditional statements here. I'm just showing two, but you could have others. And so the same with the last one. Let's take a look at this example. This is not chained. This is chained. Let's consider what the output will be for x is 5. How do we recognize whether it's chained or not? Well, this one has if, and each of these statements start with if. There's no chaining here because there's no elif statements. Can elif stand by itself? No, elif, just like else, must be attached to an if. So this one is if, and then the elif and elif pertain to this same if. They need to be indented at the same level as this if, and they are connected to this if. So these are all blocked together. These ones are not. This is 3 independent if clauses. So here we have if x is greater than 3, if x is greater than 2, and if x is greater than 1. So great. And we have the same conditions in this chain version. Okay, so let us consider when x is equal to 5. If x equals 5, is this statement true? X is greater than 3? Yes, 5 is greater than 3. How about x is greater than 2? Yes. How about x is greater than 1? Well, yeah, that's true too. So that means that all 3 of these are true statements. So when we look at this, what will happen when this is the code? Well, all 3 of these will run. So it will print x is greater than 3, x is greater than 2, and x is greater than 1, because x in fact is greater, and because each of these is an independent if statement or an if block. And there's not really a whole lot of blocking here because it's basically if and its indentation. Now let's consider the chain version. So in the chain version, we have all of the same branch guards. So we know that they're all true, right? X being 5 is greater than 3, 2, and 1. But we had that stipulation that only the first one, which is true, is the one that's going to execute. So even though these are all true, and it says elif, only the first one will execute. So x is greater than 3 will cause x is greater than 3 to print out. And none of the others will run because we have already selected one. Again, this is like the multiple choice. You have to pick the first one that's true. If none of them are true, you just select like nothing. None of them execute. So they are the same because they have the same branch guards. They are the same because they are all if blocks of some kind. They're different because this is 3 if blocks and this is just 1 if block. Each of these will execute because it's 3 different if blocks and each of the if blocks is true, so it will execute. Whereas in this case, even though the branch guards are all true, only the first one will execute because that's the nature of how the chained ones are going to work. All right, well then, that concludes our discussion of the material today. I hope it's been instructive for you to see some of the alternative ways that you could set up the if blocks. We'll get to see a little bit more of this on the next time. But thanks so much for joining us, and we look forward to seeing you the next time. Bye-bye.